Ladies and gentlemen, welcome. I'm Steve from SynHardware.com. I'm actually Sin0822. So today we're going to take a look at the G1 Sniper 5 GB top-of-the-line gaming board for a Z87 platform. A couple cool things to note on this board. First of all, the heatsink has some green accents, and black has a little orange skull here. Kind of clashes with everything, but it's still kind of the G1 type thing. So it's a green and black board, the only series that's green and black for this thing, and Gigabyte does an awesome job with their G1 Sniper series boards. They always make sure to put the best quality parts in them, to have the best quality audio, gaming LAN, and even have overclocking features. So let's take a look and let's jump into it. So let's start with what you can see. Feature-wise, first we have a heatsink. It has water cooling and has a fan. Now let me tell you this straight up, not needed. The fan isn't needed. The water cooling actually comes with little inserts. You should really never have to take them out because you should never really have to use it. However, if you want to look good or you really want to cool down the heatsink with water cooling, you just want to show off a really badass system, that's what that is there for. Also, the cool thing is this fan is angled at maybe 20 degrees below the normal level plane, and that allows, and because there's some slits that go through the heatsink here, and there are two slits here, and the air, if you put your hand here when the heatsink is the fan is on and the system's on, even though the heatsink's running, the heatsink never gets hot, so the heatsink says cool, and the fan will blow cool air out these little slots and towards the GPU. Now that's awesome, right? Because it'll cool your GPUs. However, I don't think that was the intended purpose. Maybe it is, I don't know, but I know it blows the air this way, and that you can even unplug the fan. That's a cool thing. Gigabyte has even put a light behind this little skull here, and you can unplug it and you can unplug the fan. This fan header does not take up one of the headers of the board. It's just like this little header for 12 volt voltage, and it actually has its own automatic fan controller, so it keeps everything quiet and beautiful. Anyways, so let's take a look at some of the other things. Fan headers, right? 1, 2, these are both for CPU. 3, 4 system fans, 5, 6, 7, 8 system fans, but they're actually 9. One of them is located here. So if you have a fan here, like in a case, many cases have a fan right here that blows into the CPU area or blows out, that'll power that. You have a fan here, you have your fans on the case wall, these will power that. Fans in the front, 2 here, 1 here, power that. Everything is awesome. You have you need a fan header for your water cooler pump that always runs at 12 volts, sure, take one, set it. This board has something called EC on it and an EC BIOS, and that allows for extraordinary fan control capabilities. You have 7 headers on this board. All of them can be controlled through the BIOS and software. Software needs a little work at this point. You can control them, but it won't auto load on Windows, so you got to open the software and load the fan settings. It'll remember the settings though. But other than that, fan control is awesome on this board. At least from my experience, it's been pretty cool. Whatchamacallit. So there's 6 controls in the BIOS and in EasyTune. EasyTune even has a calibrate and fixed RPM mode. BIOS is a little bit more basic to make it much easier to set up. However, you can set PWM levels and stuff like that, as well as built-in profiles such as disable, which just gives 12 volt to the headers, as well as like silent or like heavy CPU load, stuff like that. So there's 6 settings, and 2 of the fan headers, 2 of the system fans, I believe, are tied together. And then I think there are 2 headers on the board that just run automatically whatever the board wants to set it, or whatever Gigabyte wanted to do. Anyways, so let's move on. So you got the DIMMs here. Everything uses T-topology in Haswell, and actually some of the DIMMs use it, some don't, for different lines. But T-topology is being used here to its greatest extent. Gigabyte is very good with memory OC. For the new platform, which is Haswell 4th generation Core i processors, Gigabyte has CPU upgrade for CPU Auto OC, has memory upgrade for specific DIMMs for Extreme OC, and it even comes on the Sniper series and all series of Gigabyte, but only Gigabyte does that for all their boards. And it also has combined CPU and memory OC profiles. It's called Performance Upgrade. CPU socket, Gigabyte has done the Ultra Durable Plus standard. CPU socket here has extra gold, 15 micron plated. There's a lot of gold on this motherboard. Maybe if you killed it and broke the board in half, maybe you could melt down the gold and make, I don't know, a couple bucks, maybe like 20 bucks, maybe 30, because the price of gold just skyrockets, you know. Anyways, postcode display, excellent for knowing everything. Let's zoom up into the feature set for the OC features. I always love the OC features. They're always so cool, especially on G1 series, because you're not used to seeing OC features on G1 series, are you? Okay, so now we can see all the OC features, right? Power button, reset is always blue, clear CMOS always black on Gigabyte. This is the postcode. If it displays AO, that means you're in Windows. Okay, it's not an error. If it displays AB, it means you're in the BIOS. So either your monitor is not working or because the board is. So 2 switches here. Now you're wondering, why does Gigabyte have 2 switches, right? This is the dual BIOS switch we've seen before. So with this new board, since it has EC, you can actually save your settings or your last known profiles or your saved profiles even after you clear the CMOS. However, it also allows different BIOSes to save different CMOS profiles and settings. So you can OC on one BIOS, switch over to the other, and it won't have the OC on there like it did on the previous platform. Anyways, there's another BIOS here, switch here that can disable dual BIOS mode. Why would you want to disable dual BIOS mode? Let me tell you a story. Back during early Z87 days, a little bit before launch, me and a few friends were doing some OC testing. We're all overclockers doing liquid nitrogen testing. We were overclocking the base clock on a Gigabyte board. And it was the OC recovery would take a long time, and Gigabyte's very proud of their OC recovery features. And it was taking a long time, and we kept seeing an error here that would read DB. And we were wondering, what the hell is this error? And we found out that it actually stood for dual BIOS error. So the BIOS engineer comes down, and he's like, yeah, that's caused by dual BIOS checking itself, because they have patented a technology called dual BIOS, and that allows the main and backup to check each other. So basically, when you're on the main BIOS and using it, every time your computer boots, the backup BIOS checks it. It asks a question, are you corrupted? Are you okay? If it's not okay, and if it's corrupted, the backup BIOS will flash the main. And that's dual BIOS. It's awesome, right? So if you fail flashing your BIOS, backup BIOS will detect this on boot up and flash it with the backup. However, this can cause issues during OC recovery because of the way the watchdog timer works and everything like that. So you can disable it by switching it to position 2. Now, when you disable it, it makes OC recovery so much quicker. It's such a cool feature that Gigabyte put it on almost all their boards, UD3H and up. So even the Sniper M5 now has OC features and has this extra switch. UD3H has it, UD5H, UD4H, OC, OC Force, all of them have it. On the last generation, only the UP7 had it. So that's cool. We have some more OC features here. Or we have one OC feature here, and then we have some other things. So right here we have that SATA power connector, right? SATA power connector gives extra power to the PCIe lanes here. Since we have 4 of them and this board supports 4-way SLI, this extra power connector can provide extra 12 volt, extra 5 volt, and extra 3.3, which normal 6-pin power for extra PCIe won't. I recommend you definitely use this for 4-way. I'd recommend you also use it for 3-way. I also recommend if you use it for 2 GPUs, especially if they're dual GPUs. So if you have a 690 or even a Titan, which is a single GPU but uses a ton of power and is a very powerful card, then I recommend this if you're using 2 of them because it's just better for overclocking and power stability. Because think about this: the 24-pin connector only has maybe 2 or 3 12-volt cables, and those are the yellow power wires that go in here. Now you're wondering, hey, doesn't my CPU have 4 of those cables? Hell yeah, your CPU has 4 of those cables. But the issue is the CPU power plane is totally isolated from the rest of the board because CPU power has to be extremely clean. So the rest of the board gets its power from the 24-pin, and if you're running 4 GPUs that run using 12 volt, 3 volt, and 5 volt, then you might need extra power, which is this. Okay, so now let's move down to some of the other features. Now, you see a lot more SATA 6 GB per second with LJ1150. That's because of FlexIO. FlexIO allows you to trade off SATA or USB 3 for PCIe, or trade off PCIe for SATA 3 or USB. So you can do 6 USB 3, 6 PCIe 2, or 6 SATA 3. The old generations all had a fixed 8 lanes of PCIe. So now that's changed. So you can reduce those lanes and go there. But you can also do this. You can do 6 SATA, and you can do 8 PCIe, and you can do 4 USB, which is what Gigabyte's doing here because of the Soundcore 3D uses a PCIe lane, unlike Realtek codecs. Realtek codecs use Intel's HD audio that's built in and don't use a PCIe lane. However, the Core 3D does use a PCIe lane. Not only that, the Intel NIC and the Bigfoot NIC on this board also use PCIe lanes. Plus, look at all these single PCIe slots. They also need PCIe. Not only that, but this Marvel controller here that provides 4 ports also uses 2 PCIe. So we have to have 8 PCIe lanes from the PCH. So Gigabyte chose the 4-8-6 configuration. Now that's okay because we still have 10 USB 3.0 ports, right? See one here with the on-off charge. Gigabyte has just added USB 3.0 on-off charge, a new thing for Ultra Durable 5 Plus. There are actually 2 little chips here, and they're really required for it. Let me move around here 1 second. Yeah, they're actually the TPS 2546 chips, and I have to move over here and get a good angle on them, and they're right here and right here. These two chips provide USB 3.0 extra power. They're especially made for USB charging. Down here, this port doesn't have it. All the new boards come with a little plug in the port on the bottom one that's not on-off charge, and that's another USB 3. This USB 3 internal header goes directly to the PCH. The other 8 on the board go through hubs. So 2 of the USB 3.0 lanes go here. That's half the Intel USB 3.0. The other half USB 3.0 go to 2 hubs. One of them is here, and 2 ports go to the back, and 2 of these ports go to the hub. go to the on-off charge port. So that's how Gigabyte gets so many SATA ports. USB 3. One more thing. A Marvel SE9230 takes in 2 PCIe lanes and outputs 4 SATA 6. Now, usually Marvel is not really liked, except when they use the dual ports. The dual PCIe add-ins. Now, that's not much different than SE917, which uses a single PCIe lane for 2 ports, and this is using 2 for 4. But think about it this way. If you just plug in 1 SATA or 2, they still get the 2 lanes. So that's its benefit, okay? Now, let's count the fan headers. I don't think we did that yet, right? I don't think we counted the fan headers yet. So the fan headers, actually maybe we did count the fan headers, my bad. Let's look at the audio. There are 9 fan headers, right? I went over that. Sorry, I'm getting a little absent-minded these days. So now let's zoom in on the Core 3D audio. I love the Core 3D audio implementation on this board. It's really top-notch. I'm really impressed with what Gigabyte's done with this platform. So, Core 3D audio. You see now Gigabyte has put a gold-plated EMI shield over the chip. Now this chip uses a PCIe lane. It's not an audio codec like Realtek 1150 or 898 is. It actually uses a PCIe lane. That's better for a lot of things, especially the bandwidth it can handle and stuff like that. But audio is not really that important when it comes to bandwidth. But let's take another look at the other things on the board, because the Core 3D is well known. Now, Gigabyte's using the Nichicon Muse ES and MW series, these yellow and green capacitors. These are very, very high quality audio caps. And these are low profile on purpose, these Muse MW series, because they don't want the GPUs to conflict. Then right here we have an OPA 2134P amp. Now this is very commonly found on high-end audio products. Gigabyte's using it here, and they're doing a good job with this. This requires extra power. So how does Gigabyte give the extra power? They use a TPS 65130, I believe. 65130. Yeah, TPS 65130, which is here, which is a DC-DC converter, but it's also a boost. So it can input 12 volts, right? No voltage on this motherboard can be higher than 12 volts unless it goes to a DC-DC regulator that pushes it above 12 volts. Well, that's exactly what this is, and that's required to support a wide range of amps. This board also comes with the LM4562. That's from Texas Instruments as well. Burr Brown actually makes an OPA amp, and Texas Instruments also owns Burr Brown or makes their amps for them. So LM is also a Texas Instrument one, and LM is much better with highs. This OPA is better with lows, so if you really bass heavy music like rap or hip hop, that'll be best. Now, gaming, I actually prefer this, but if you like highs, like classical music or jazz, then the LM would be better for that. Here we have a DRV632. And it goes to this gold-plated internal audio header. Now, Gigabyte has gold-plated this one for better corrosion resistance and signal quality. Here we have a line of PCB that's been cut out. And you can't really see it, but you know on the ROG series from last time, the Maximus 5 Extreme, everyone was really impressed by the red line glowing through the motherboard PCB. Well, Gigabyte has this too now, but with green. Now, there's a reason that this actually has some functionality to it. It separates. Gigabyte has sectioned off the PCB, so this is separate. This little area with the audio is totally separate from the rest of this, because there's a lot of noise here, and a lot of audio signals are analog, and analog is very susceptible to noise. So Gigabyte has added basically a line through it, which has already been done, and they actually found that this does help. They have actually an echo chamber in their headquarters and other audio testing rooms where they can test out how it is compared to the old snipers, and this audio is much better even without the OPA amp. Using the DRV632 through the front, they can also compare to the DRV632 and the G1 Sniper 3 because they use the same audio capacitors and the same codec, which is a CA0132. The Core 3DI, same controller, quad-core audio controller you find on like $150 sound cards, you know? So using it here, and it's not bad. So the audio is separated through there, and you can actually see the LEDs on the back side, and they're not bad. You can also see the audio controller here is gold-plated. The outputs are gold plated. Let me turn this around and pull up a little bit so we can zoom out. Okay, so now that we zoom out, let's take a look, right? This is a Toslink. Toslink means it has this SPDIF out digital, which is kind of like the laser beam type SPDIF out. Gold-plated audio connectors, 2 NICs, right? One is Intel and one is Bigfoot. Then you have 6 USB 3.0, all from hubs. The hubs are actually beneficial here because they don't have the USB polling issue after S3 sleep that the native Intel does, because the hubs are able to wake up the ports. Anyways, to dual HDMI, the reason for this is one is for audio, one's for video. I actually had to ask a project manager at GIGABYTE, at Computex, about why they had 2 HDMI, because it was really perplexing. Then we have a display port here, SPDIF out optical right here. And we have 2 USB 2.0, which are beneficial if you're installing on Windows XP or 7. Windows 8 has built-in AHCI drivers, XHCI drivers for USB 3.0. However, if you're installing and you only have USB 3.0 like on a UD4H or something, or UD3H, then you can just disable XHCI and all these ports would be 2.0 mode. PS/2 from the ITE Super I/O, right? So now let's take off the heat sinks. And actually wanted to show you these audio LEDs on the back. I've already kind of taken out some of these heatsink screws just so I could do this and take off the heatsinks for you guys. So now that we're looking at these LEDs on the back, you can see they illuminate. There are a lot of them, right? If you compare it to the backside of other vendors, this board has tons of audio LEDs. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19 audio LEDs, okay? Now, that'll actually illuminate the whole board. Even on the other side, you'll see a glow, and you'll see a picture in my review that highlights this, and it's pretty cool. So, now let me unscrew the heatsinks, because I really want to show you guys some of the cool stuff. You can take a look at the back of the board. So, GIGABYTE has used an 8-layer PCB on this board. That's the first time any G1 Sniper series has had it. The original G1 Assassin had 8-layer PCB as well. However, the creative implementation on there was a ton more chips, the XFI. But here it's a little different. It's not as many chips. So, now watch this, right? They're hanging because they have wires connected to the board. So I'm doing this so you don't have to do it at home. And this is kind of dangerous, and you can damage your board very easily like this. You can also pull out these plugs and everything like that. First, we need to take out the plug here. Let me focus a little better. Yeah. So pull out this plug here. That's for the audio LED inside this heatsink. Now, you can see there's no actually real thermal paste here. Instead of a thermal pad. This thermal pad is extremely thin and actually rests on the copper of the heatsinks. These heatsinks come from a different manufacturer and they're a little higher quality than before. But this thing unscrewed. For some reason, when you try to unscrew these heatsink, sometimes these little screws actually unscrew too, which is a little annoying. But this PCH has a much lower TDP than before. Before it was 6.7 watts on the Z87. This is only 4.1 watts. You can run this without a heatsink. Here we have a PLX chip though. This needs thermal paste because this gets hot. Okay, now let's take a look at this one. Thermal pads on the MOSFETs. And I just unplugged the fan. So the fan you can actually just unscrew. And I wanted to show you guys the angle the fan is at, right? Right at about 20 degree, maybe 15 degree angle below horizontal. And let's hold it horizontal to the PCIe port. And then you can see out here there are a couple slots, and that's where the air blows out of. You can see the heatsink from different angles, maybe see what you want. Oh, and there's the heat pipe, which is just hollowed out, and it's copper actually. Very strong, and the water flows through it. So, yeah. It doesn't really flow through different channels. That's a PLX chip, and you can see the contact made here is very good. And this is actually thermal paste that's already on my finger. So, yeah. Yay! I'm already dirty. Okay, first thing I'm going to cover is the VRM, because that's what I like the most on every board. So, the VRM here is run by IR3563B. This can go up to 2 MHz switching frequency, but it's not. We have 16 phases of IR3550. No motherboard in production right now has higher output except the Z87X Power and the Z77X-UP7. Those are 32-phase boards, but they might also not have high output as this board, because those chokes on those boards can maybe output, like, I know the UP7 could output 25 amps. These are about 35 amp. But on the X Power, I'm pretty sure it's a little lower than that per phase. But it doesn't matter. This is 16 phases, way more than enough. You can run this without a heatsink. It's not even needed at all. I swear to God. I run it without a heatsink many times. In my engineering sample boards that I get for testing, I do a lot of testing for GIGABYTE. and they don't have heat sinks. Anyways, you see the capacitors here, they're black. Gigabyte has custom got these capacitors made by Chemicon, and they're a Japanese company, and they're very well known for their high quality audio. Their high quality capacitors in general. They're one of the best one of the best capacitor companies. Sorry, I keep saying audio for some reason because of thinking about those Nichicon ones. So that covers the VRM here. This is a true 8-phase VRM doubled to 16 by IR3599. So that's interesting to know. Now the memory VRM here is dual phase. It uses the IR3570. IR3570 is a 3+2 phase, so 2 of the phases are going to these Renaissance Power Pack MOSFETs, and IR3598 works as a dual driver here instead of a doubler and provides the outputs here, and then 2 of the other PWM lanes go all the way here to the PCH. You see some MOSFETs here and some little MOSFETs here, and they provide different power rails to the PCH. Yay! Okay, so we keep going down the board in this clockwise position. So I was talking about these TPS2546, and these provide the USB power, right? These 2 extra USB powers. So let's move the board along a little bit. This is the Marvel SC9230. Let me see if I can get closer. I don't know if you can actually read that. Alright, so that's a good focus, right? Okay, so now let's switch over here. This is the IT2870F, alright, IT8728F. And this does fan control, voltage monitoring, stuff like that. However, you need to understand this. This doesn't have so much fan control. Maybe you can control up to 5 fan headers. However, most of its functionality is given to other things, such as voltage monitoring, PS2, maybe clocking the PCIe lanes, stuff like that. So on this, it's only providing maybe 1 or 2. However, there's a chip here that's an IT8790E. You won't find a datasheet for it, and this is another BIOS for this. This is the EC BIOS, this is the EC chip. This provides all the extra fan control and all the extra cool features like different CMOS profiles, or different overclocking profiles, and ability to save overclocking profiles after clearing CMOS. That's what this chip does with its BIOS that saves that extra information. With that, Gigabyte's able to give you so many more features for overclocking, for general use, makes the boards really good. ROG boards have this, they've had it for a while. Gigabyte is first implementation of EC, and they code it themselves. This actually gives out 12 volts all the time, so if you're a modder and you don't like that light inside the thing, you can just use that. Okay, here's our first hub. Right here, this is a what is it? D72010. This is made by Renaissance/NEC, and they're extremely good. They're pioneers in USB 3.0. This is a 1-to-4 hub, so you input 1 and output 4, and it goes to the 4 USB ports. So this one goes to the one front panel on-off, and 2 to the back that are closest to it, so closest to the audio toss link. Then you have these PCIe lanes here. These are ASM 1480s, PCI 3.0 switches, and we'll go over the PLX at the same time. So here we have a PEX 8747. This is a 48-lane port, so 16 up to CPU, 32 down to the lanes. It has its own VRM here, single phase by RT8120. And so 16 lanes go here, 16 lanes go here. If you do 4-way or 3-way, these 4 switches will switch 8x from here over here. These 4 switches will switch 8x from here, here. So that supports your 4-way and multi-GPU. These lanes get directly from the PCH 1x. We've already gone over the audio, and I think we've covered most of the stuff. Let's cover the NICs. Okay, so Intel, this is the Clarksville NIC configuration. This is an Intel physical layer device, a PHY, and that works with the integrated Gigabyte Mac in the PCH, and it gets the actual physical layer device that gives a port. It might be this one. This is the Bigfoot NIC 2201. There's also 2205 on some MSI boards. That's a cost down version of this one. They have the same functionality. This one costs a little bit more because it's smaller, and it's integrating it is a little bit easier because it's smaller and it saves size. I mean, saves room. That's the reason the Gigabyte used this instead of the E2205. It also provides the same stuff, same feature set, but it costs a little bit more than the E2205. And this is the E2201. And then we have a couple chips here. This is the other hub, right? And these two are level shifters. So the native output from the video of the PCH is actually DisplayPort or digital video, and that works natively with DisplayPort. So there's no need to use these level shifters for DisplayPort. However, there is a need for HDMI to use these level shifters, and 2 of them are here to give 2 HDMI ports. These are made by NXP. I think I've covered everything on this board. Oh, one last thing. The BIOS ROMs for dual BIOS here both have an LED, but these BIOSes are twice as big as the BIOSes for Z77. Alright, so that's pretty cool. Anyway, so that should be there's 128 megabits instead of 64 megabits, and that means there's 16 megabytes instead of 8 megabytes that the previous generation was. Wow, that was a mouthful. Anyways, I hope you enjoyed the review, and if you have any questions or comments, please post them. Thank you for watching, and have a nice day.